And let me just go ahead and delete this. I want to show you how we can create a column of numbers with a certain increment. We're starting at 2, and you can just start with 2 values that are separated by an increment. I can highlight both of those, and then I can go down here to the lower right hand corner where it turns into a solid plus sign, and then I can click and drag down, and you see at the lower right hand corner we see the value I have if I were to stop dragging at that point. So now I'm down to 4.0. I'm going to go ahead and unclick that. Let me press delete. Another way to do this, if I start at 2, I can go up here on the home tab, and over here on the right there is a fill. So there's an arrow here, so you can do a series. Click on series, and it asks us, is this a series in a row or column? We're going to create a series in a column. This is going to be linear because it's going to have a constant increment, and the step value is going to be 0.2. The stop value is going to be 4. So we're going to go in increments of 0.2 until we hit 4, and I can go ahead and click OK, and I've created that series. I think the first way I showed you is a little easier. Unless you have a really big column of data, then sometimes using that fill series is more useful. So I've got my L in feet. I can also convert that to meters then. What I just created up here is known as a live solution. So we can change L here. I can change this to 2.6, and when I press enter, look what happens in cell E7. It automatically updates. So this up here, typically when you're creating a case study, you'll create kind of a area of the spreadsheet that does it for one scenario, and then you will create the case study for multiple values of L. Now in some subsequent screencasts, I'm going to show you how to use the data table, a one-way data table. The one-way data table tool is the preferred way to solve these case studies. If you've already got your spreadsheet set up for a single scenario, then using a data table for multiple scenarios is way easier if you know what you're doing. But I'm going to show you here a different approach where we just use columns. So I've got my input in feet. We need to convert feet to meters, so I can multiply that by the conversion factor. So 2 feet is 0.61 meters. I can click on that, double click on the lower right hand corner to auto fill it down. And then what we're going to do is, for that value of L, we're going to calculate delta in meters. So I'm just using this formula here for delta. So I'm going to plug that in, equals F times, now the L I'm going to use, I'm not going to use capital L because capital L is just a single value. I'm going to use the adjacent cell, which is L in meters, because that's what's changing. That's going to be a relative reference. And I'm cubing that, divided by 3, divided by E, divided by I. And that's going to be the delta in meters. And I can double click down there to autofill. And the last thing we need to do then is to convert meters to millimeters by multiplying by 1,000. I can take that and double click it down. So that's our result. If I wanted to plot this, that's my independent variable L. And we want to, on a plot, look at the deflection at those different values of L. So I've selected both of those columns of data. I'm going to go up here to the Insert tab here, and I'm going to go to a chart. Click that. And then if you want, you can adjust kind of the formatting of this. So I just added some titles there. I formatted that, and this is what it looks like. So as you may have predicted, deflection is a cubic function in terms of L, and that's just because of this equation. Delta is a cubic function. It depends upon L cubed, and that's why we get the curved line in the plot. So again, this is one way that you can do a one-way case study. The preferred way, I'll show in a subsequent screencast, is using a one-way data table. Thanks for watching.